Yep. Forever card number 8, but we need to fill it in first before you guys make it an official forever. So how many, guys, look in your notes. How many forevers do we have this chapter so far? And we're only in section 2.1. 3. Yeah, what's the first one? Look back in your notes. Definition of derivative where it's what equals the limit as h goes to 0 of f of x plus h minus f of x all over h. F prime of x. F prime of x equals. Okay, what's forever card number 7? Okay, good, but remember that's not enough. So what's on that card? Alternate forms, where it's not f prime of x. Technically, it's f prime of a, where they say find the tangent line at x equals a number, x equals a. But there's a second part to that. What's the second part? Tangent line. What slope do we use for tangent line? Point slope, y minus y1 equals m times x minus x1. Where does that one get tricky? Where does your x1 come from? Yeah, point x equals a. Where does your y1 come from? You plug it into the equation. That's what I was looking for. The y1 is f of a, where you take the a and you plug it in, solve. Where does the m come from? Prime of a. Why? Look back in your notes to the very beginning of 2.1. Verbal description of derivative. Why does f prime of a go in the m spot? Because derivative is what? Slope of the tangent line, right? Okay. Slope of the tangent line, slope of the graph. And what's that third one in that box? Verbal description, slope of the tangent line, slope of the graph. I don't think I heard it yet. Instantaneous rate of change. Yeah, the third one. Instantaneous rate of change. Okay. Connection between differentiability and continuity. Connection between differentiability and continuity. Let's see. I want to make this a little bit more obvious to you guys. Can you guys grab out your graphing calculators if you have them? If not, hopefully at least one person per group does in turn so you can see their screen if you don't have yours. Graphing calculator. It's okay. No one in your entire group? Does any group have 2 and they can share? AJ, perfect. Who's going to take it? Nick, because he's falling asleep. Okay, here we go. Everybody turn. You got to be able to see the screen. Okay, y equals, I want you guys to graph absolute value of x. Absolute value of x. Absolute value of x. I want you guys to look at the graph in Zoom Standard, and I want you to be pondering the slopes of that graph. There are only 2 of them. I want you to be pondering the slopes of that graph. There are only 2 of them. So we have f of x equals absolute value of x. You're thinking about the graph, which you should already know. I know. It's a basic graph. I want you to ponder the slopes of the graph. Question, what would the slopes be of this graph for x less than 0? Ponder and talk in your groups. I don't want to hear answers to me yet. Go. What would the slopes be for x less than 0? Then I want you to think of what would the slopes be for x greater than or equal to 0. Take a second. I already gave you a hint. There are only 2 slopes. What would the slopes be less than 0 for x less than 0? What would the slopes be greater than 0? Okay. So, absolute value of x is being plugged in. Let me clear out all my stuff. Okay. Where'd you guys find absolute value again? Yeah, math and abs. Is there somewhere else to find it? Shortcut menu. Alpha, what? I don't know, any of these. You can do alpha that one, you can do alpha that one. Ooh, hey, it's a little shortcut. Anyway, you could just do alpha, window, enter. But anyway, absolute value of x. Zoom Standard, got it. Why did I say there are only 2 slopes? Why is there 2 slopes? There's a line which has what kind of slope? Constant. One slope for the whole line, right? Rise over run, even though it's like a negative rise over. Anyway, downhill, one slope. But what happens at 0? So other slope. So how many lines comprise the absolute value function? Why? Because wait, isn't absolute value just a piecewise function? Couldn't I rewrite him to be one line, a negative x for x less than 0, another line, positive x for x greater than 0 or equal to. If I plug in a positive number, it stays the same. If I plug in a negative number, the sign flips. So maybe it makes sense there would be two different derivatives, and since they're lines, two different slopes. So what did you guys figure out was the slope for the less than 0 side? -1, mx plus b, -1. What's the slope for the greater than 0 side? So here's my question. What's the slope at 0? Hey, can your calculator find derivatives? Yes. I want you to go play in the different menus and find the one where you can find a derivative. P.S. We're on a graph, and there's a certain menu where you always go to do anything on a graph. What menu do you go to do anything on a graph? A max, a min, a 0, an intersect? No. Didn't we talk about something yesterday to do with notation that might help you find the right button? Psst, 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 psst.
Bingo, we found it.
Did you find it? What'd your calculator say? Second, trace. dy dx is number 6. Pause. All I see is the point 0, 0. I think I need to tell the calculator something like which derivative I want. Oh, hit dy dx. Which derivative do you want? The one at 0. Go.
We were right. That's crazy.
Now, I want you guys to do second quit. Ready? I want you to go find the other place where a derivative hides, which is math. I want you to scroll down the math. Do you see anything that might have anything to do with derivative? Ooh, n derive. What number is that? Number 9? Number 8. There he is. So, wait a minute. I don't even know what to do. Pause. Verb. Derivative. dd who? So d dx. Of, this is like function notation, of f of x. Who do I want to take a derivative of? No. Yeah. Absolute value of x, alpha, window, enter, absolute value of x. Such that, you guys learned the such that line from me last year. We've seen it this year a little bit. Such that x equals what? Go. Here's the struggle. Let's go online to a really cool website called Wolfram Alpha. Anybody know about Wolfram Alpha? No?
Wait.
Wolfram Alpha is the computing language behind why Siri can do math. Siri can do math. This, no. Funny. Wolfram Alpha is a major computing engine that actually has this whole computer software called Mathematica. Lots of people use it in the higher maths and applications, etc. But anyway, cool thing about Wolfram Alpha is that it can do calculus. There are apps, there are derivative calculators, etc.
This is crazy.
Is it really not showing you? Oh, there we go. Do you see it?
Yes.
Oh, I can't go pro. I don't want to pay money. Undefined. Wait, I don't get it. Our calculator said 0, whether we were in the graph or whether we were on the home screen. Y is Wolfram Alpha, which is a major computing engine and can find the derivative of basically anything. Why is it telling me undefined? What happens as you come from below? What's the slope of the derivative? dy dx. It shows deltas, but -1. What happens as I come from above for the derivative? +1. If the derivative is defined to be f prime of x, f prime of a equals, what's that very first thing in either of those? A derivative is defined to be defined by a? Forever card 6, forever card 7. F prime of x equals what? What starts that off? F prime of a equals what? Limit! A derivative is a limit. A limit of what? A limit of slopes of secant lines. If a derivative is a limit, question, what happens if as I come from below I have one slope, as I come from above I have another slope? What happens in between? The derivative does not exist. Why? The one-sided limits don't agree, and the derivative is a limit. Once we get into section 2.2 and get into shortcut rules, we're going to lose the idea, and our calculator doesn't help. Thanks, Mr. Calculator. Remember how he has limitations? He approximates stuff, and usually it works really, really well. Guess what? Calculator is wrong. Calculator's wrong. Why? Because as you look at your graph, one slope from one direction is -1, one slope from another direction is +1. If the derivative is a limit, those need to agree for the limit to exist. Does it agree? No. So what's true about the derivative? It does not exist. So here's where or why we were talking about all this. What's this card say? Connection between differentiability and continuity. Connection between differentiability and continuity. If a function is not continuous, it can't be differentiable. If there's a jump, can't be differentiable. If there's a vertical asymptote, can't be differentiable. If there's a hole, can't be differentiable. There cannot be a slope at a point that does not exist or where there's a break. Okay? If a function is not continuous, it cannot be differentiable. A derivative will not exist at a discontinuity. But if a function is continuous, may be differentiable. We're going to write except for, it's going to be continuous. If it's continuous, it will be differentiable except for sharp points and vertical tangents. Here's why. Sharp points like the one that we just saw. Sharp points like the one that we just saw, which would be absolute value of x. F prime is equal to, if f is equal to absolute value of x, just our example, -1 from one side, +1 from the other for x less than 0, for x greater than 0. But the derivative is defined to be a limit. And if as I come towards 0 from below and 0 from above, what's going to happen to my derivative? Since the limit as x approaches 0 from below of f prime of x does not equal the limit as x approaches 0 from above, of f prime of x, I would say f prime of 0 does not exist. Vertical tangents is a whole other beast. Not super bad, though. So what's going on for sharp points? F prime of 0 does not exist because the one-sided limits do not agree. What the slope is supposed to be on one side, what the slope is, well, what the slope is on one side, what the slope is on the other side, they do not agree. The limit does not exist, so the derivative does not exist. Vertical tangents. Let's use a different example for him. What if I was to do something like this guy? Except that guy's a little too slanty for me. Let's do this guy. Let's change our function and see if our calculator can do better on this special case. What if we were to do something like Hey, basic graph. What's a graph that looks like that? That's all sideways. Yeah, well, x cubed is this guy. Who would be that guy? His inverse? Not square root. Cubed root. So if we went to math, I think we can actually do cubed root, can't we, number 5? Or we can do it to the 1/3 power. So the cubed root of x, let's go see if our calculator can do that one. So graph. Zoop, there it is. Okay, so let's go on in and let's see if the calculator is okay on this messy case at 0. Finding the derivative. 100. Let's see if I was to zoom in. Does this change? I really thought our calculators were better at derivatives than this, but I guess they're really, 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 really bad at special cases. Oh, still 100. Let's try this guy. What if I was to do him, but with a cubed root of x instead? How bad are you? Math, cubed root of x. Still 100. All right, let's go to Wolfram Alpha, which can compute to better accuracy than this guy. Let's do x to the power of 1/3. Ooh, what do you guys see? Infinity. I think technically it's positive infinity. I don't know why there's a little slash on top. I would enlarge it, but I have to play. Oh, complex infinity. That's interesting. We don't even talk about that. Infinity? Can anybody look at the picture and figure out why we should know that the limit is infinity? I should say the derivative is infinity. What kind of lines have infinite slope or undefined slope? Vertical tangents. If the slope is vertical, sorry, if the tangent line is vertical, what does that mean about its slope? Ooh, if a tangent line's horizontal, what do we know about that slope? Not constant. That'd be a constant slope. 0. It's flat. You have no slope. You're not going downhill or uphill. You're just going, right? Horizontal tangent line, slope equals 0. Vertical tangent line, what would happen if you skied it? Come on, we talked about it last year. You'd be undefined, real quick. Good. Okay, so undefined slope. What does that mean? On this guy, f prime of 0 equals infinity, or we could say undefined. So both of these are problems, just in very, very different ways. This one, sharp point, the derivative does not exist because the pieces have different slopes as you come in towards it. This guy, the derivative does not exist because he's infinite. And if we were to have the derivative, we'd see that in that you would plug in and get a number over 0. So what's going on with continuity and differentiability? Differentiability, term from yesterday, differentiable, able to be derived, aka the derivative exists. When will a derivative not exist? If the function is not continuous. When else will the derivative not exist? If I have a or a. And then the very bottom one is, oh, P.S., by the way, if the derivative does exist, the function must have been continuous to begin with. This is forever card number 8. Shoop. Okay. Let's do examples to the end. What do we got? All right, get down your function. F of x is equal to 1 over x squared. A is equal to -1. In this section, do you know shortcut rules yet? That's not the right question. In this section, are you allowed to use shortcut rules yet? No. So what are you going to use? Forever card 6 or 7. Why do I say or 7? What do you need for your tangent line? Don't you need f prime of a? So what are you guys going to do? Find f prime of x and then plug in a, or find f prime of a? Forever card 6 or 7. You as a group talk it out. Choose which one you want to do and go. Find me f prime of -1. Choose in your group. Forever card 6 and then plug in a at the end, or 7 and you go straight for the answer. Forever card 6 or forever card 7. And go. I'm not giving you a lot of head start, so get going. Pick one. Once you pick one, you're supposed to be solving. I'm coming. I'm coming. Coming. Quick vote. Who's doing f prime of x? Forever card 6. Cool. Who's doing f prime of a? Forever card 7. Okay. I saw more f prime of a's, so I'm going to do that. What do you guys want? The first one or the second one? Forever card 7 has 2 options. Which one looks better? The second one? Joyce said the second one. Okay. She said 2. What is the second one? X goes to A, right? I'm pausing because we haven't done that one all together as a class. So let me give you guys a second. I'm just plugging into the formula. The limit as x approaches A of f of x minus f of A all over x minus A. Now get out in front of me. I'm giving you a handicap. I'm letting you get ahead. Solve the limit. Plug in. 0 over 0. Keep going. How? You have an f. Go get them. Put them in. Plug it in. Plug it in. Thomas is still gone, huh? Bummer. Solve your limit. Solve your limit. Yeah, Nick. Yeah, I was just noticing that. Yeah. But don't worry, bud. Actually, we're going to go over the answers in just 1 second. So then you can just turn it in when we turn it in again. Take yours, pass around. Take yours, pass around. If you didn't turn it in, you're getting a little bit of grace. Take yours, pass. Take yours, pass. We never went over the brain busters on the back. And a few of you guys were either gone on Friday or something happened where you didn't give it to me. So we want to go over the answers in just a second. And then I'm going to collect them back so I can read them. Can I play? Can I go? Do you mind? Okay, let me zoom in. What happened when you guys plugged in -1? 1, right? Did you guys try plugging in? It was 0 over 0, wasn't it? Still 0 over 0. Wait, what can we do up top? Factor it. Good. Isn't it a difference of squares? Now what can I do? Did you guys get here? Uh-oh, I see a lot of writing. Can't we reduce? What happens when you plug in negative 1? 1 minus a negative 1 is 1 plus 1. That's 2. And 2 over negative 1 squared. Got it. Questions on using the definition. Could we have done the first equation for f prime of a? Yeah. Could we have done the definition of the derivative f prime of x and then gotten our final derivative and then plugged in a? Yeah. But does this work? I think so. Do you guys follow my work? Does it all look legal? Mm-hmm. So how do we use this too? How do we use f prime of a to make a tangent line? We just talked about it. Plug it in. Sure. So y minus equals x minus, who are we missing? F of a, meaning f of negative 1, right? Who are we missing here? F prime of a and x minus a. But you're right, that is just 2. It's the slope of the tangent line. It's the derivative guy. X minus negative 1 is x plus 1. Who's the only guy we're still missing? And we already did that, but if we needed to, we could do it again. Doesn't it just mean what Janelle said earlier? Plug it in, and what do you get? Got it. If you were matching it, you might need to get y by itself. Guys, double check my math. Wouldn't it be 2x plus 2 plus 1 plus 3? Is that right? Okay. Now, hold on. What on earth would we do if they said instead of finding the tangent line, find the line perpendicular to the function at x equals a? Perpendicular to the function? Huh? Couldn't we do the graph of 1 over x squared? Couldn't we even mark the point negative 1, which hits at positive 1? What do they mean perpendicular to? What's a tangent line do? Doesn't it skim? Sorry, you can tell I'm doing pre-cal. We're doing inverses right now. F prime. That's the tangent line, but how do I do perpendicular? Guess what we make it perpendicular to? The tangent line tells me what's going on at an instant, what the slope is at an instant. So how do I do a perpendicular line? I take the slope, and what do I do to it? I say the perpendicular slope will be negative, aka opposite, and also reciprocal, so negative 1/2. So then, wait, how do you make a line? You forget so soon. How do you make any line? Point slope form, y minus y1 equals m times x minus x1. What's the point? The exact same one I used a second ago, which was y plus, y minus 1. Same point. X minus negative 1. Same point. It's the same exact point because I'm still doing it at x equals a. So a and then f of a. But what changes? I take the derivative and I say, nope, opposite reciprocal. Does that make sense to know? If it's parallel, you would just steal this slope, same slope, but then look and see if they're telling you to go through a different point. So they might change up the x1, y1 to make it somewhere else. Does that make sense? And then if they don't, then go ahead and just, if it's parallel, you could just use the same point. Nope, just 2. Because parallel means same slope, so same as the derivative. Does that make sense? So that's the slope that you would use. Okay, this guy. Last example. Find the equation for the line that is tangent to. Let me give you a second. It's time for you to choose. Do you want to use forever card 6, f prime of x, and then plug in a at the end? Do you want to do f prime of a, variation 1, alternate form 1, or alternate form 2? Pick one and start plugging into the limit formula. Pick one and start plugging into the limit formula. See how far you can get. You guys can do this. Can't find a tangent line until you find me a slope. Just tell me a forever card, guys. 6 or 7. Which one are you using? Which one? 7? Okay. Then I'm going to go ahead and do variation 1 just so we have something different. Alternate form 1. So I did plug in a plus h or 0 plus h. Because 0 is in the x spot. That's why I'm using that for my a. Plugging in 0 for f of 0. And you guys did a very good job of choosing forever card number 7. Because forever card number 6 would have had you cubing in x plus h. Ugh, that would have been nasty. As it is, we get h cubed minus 2h plus 1 minus 1. That's not bad. Did anybody get to negative 2 before me? Anybody? Okay. I had one head nod. Anybody else? We're on the right track, though. Were you on the right track, though? Now, is that the final answer? Nope, that's just the derivative, and the derivative verbal description is what part of a tangent line? Slope. So can't I just take negative 2 and plug him straight in the slope spot? Who goes in the x1 spot? 0. Who goes in the y1 spot? Oh, nice. Look, they gave it to me. But I could have plugged in 0 and gotten 1 also. So I could go ahead and, if we needed to simplify it, negative 2x plus 1. But if it was a long answer, stop there because it's right. Now, in homework, I think about to the 20s-ish for this example, in the sense of finding derivatives at points. It says graph both on the same screen. What they're talking about is in your graphing calculator. You can graph your original function and then graph your tangent line. And what should you see it doing to the original function? Skimming it. Good. But, guys, somewhere around the 30s, it does get a little funny. And, Janelle, actually the question is a little different. It says parallel to the given line. So you would actually find your f prime of x and set it equal to the m of the other line, because you would need them to be the same. The m of one needs to be the m of the other. So it gets a little weird in like the 30s, but there is a video. One of the problems is pink. Then in the 40s, it gets a little normal again. In the 50s, it gets a little weird. In the 60s, it gets normal again. So just keep going in homework. Don't get stuck. Just pass over something or skip it if you need to. Hold on to your reflections because we need to go over that brain buster, and I don't want to grade it until you guys get a chance to talk about the answers. So first thing tomorrow, let's get those turned in after we talk about the answers to the back. Sound good? All right, bye guys. Yeah, there's more random seats, not two.
Wait, are the things on the back for to read?
Oh, we're going over.